Now let's take some time and get into the nuts and bolts of the actual control. This control, as you can plainly see, has specific information on the screen, and right now it is up and operational. Noted on the screen you see a specific amp draw. That would be the amp draw of the highest single registered leg out of the three when it's set up for three-phase, or just the amp draw of the single leg if it's set up for single phase. You'll also see a temperature. You'll also see a number of trips, which is currently 0, and a max, meaning maximum number of trips before it goes into manual reset. We will talk about all of these features. First off, it's important to note, you are required to supply 24 volts continuous to this control in the bottom left-hand corner of the control. If you do not supply 24 volts continuous and you use it off of a feed that would be killed when it goes off on safety, the control will not function correctly, so that parameter must be observed. The control consists of two aspects on the top side of the control itself. These two aspects, one is on the left side, one's on the right. The one on the left side is the relay with a common, a normally open, and a normally closed circuit, so that you can configure the control portion of the circuit in whatever means is necessary to achieve proper operation. Normally what people do with this is they will wire this in series with the voltage going to the coil on the contactor, and you will automatically break that circuit in the event that there's a failure. So I'm showing this control circuit light on right now, which means that we are allowing power to flow through to our device. The other side of this is the alarm circuit. The alarm circuit has a very similar configuration. We have a normally open, a common, and a normally closed side. You can configure the alarm any way you wish, and we can set it up in multiple configurations. So let's dive into the control. First, you have 4 buttons. You have a mode button, an up, a down, and an enter. Fairly simple, and it's the only 4 buttons you're going to need to do anything and everything with this control. If I press the mode button once, the first screen it enters is a screen that allows you to go ahead and reset a manual reset. That would be the first thing. All you need to do to reset would be to press enter, and it says resetting trips. Very straightforward. Anytime you come up on the control, you can reset any trips. So let's move on. 2 presses of the button will give me the current trip settings. By entering that menu, it brings up some sub-menus which allow me to specify the number of phases, which I can set up as 0, which means it's only going to read temperatures, single phase, or 3-phase. By choosing any one of those up and down and hit entering, it locks that one in. Next thing, it's going to ask you to set the actual amp trip level. This is the full load amps of the compressor, the run load amps of the compressor, not the LRA. Do not use the lock rotor amps. We're not interested in that. We're interested in the full load amps. So what you're going to do is set that by going up or down here. As you can see, I can go up or down. Okay? And I can set my level wherever I desire. Once I set my level, I can set the percentage of phase imbalance I will allow. This control comes out of the factory with a 12% variance in phase imbalance. That's usually a good starting point. I don't recommend going too much lower, nor do I recommend going too much higher, because what you're looking for is this to protect that compressor when that imbalance gets too great. If you're in an area where you know phase imbalances are a major issue, you could raise it slightly, but try to stay within a reasonable number. Next thing, this is very important. This would apply especially to scroll compressors, and it would apply to screw compressors. This will check phase order to verify that the order of the phasing is such that the machine will turn in the correct direction when it's started up. As I'm sure you're well aware, many of the compressors, such as screw compressors and scrolls, that are on the market today will not function correctly unless the direction is correct. The installation of this control allows the control to check the phase, and it will immediately shut the system down on detection of a phase imbalance. Now, this is not just a good thing at the time of install, which is excellent. It's also good in case somebody comes into your building, does electrical work, and then accidentally changes a phase on you going up to the box that your particular piece of equipment is attached to. This would stop it from running in the incorrect direction, and it will keep it running correctly. So coming back to the main screen, that's what's in there. Now let's go back to another screen we'll show you. Temperature settings. You can set temperatures. You can set a discharge line temperature sensor here, and if you want to use that, you push the next button, and it will also ask you what type of sensor. There are several types you can use. You can use a 10K, you can use a PTC, or an NTC. So either one will function, any one of those three will work, as long as you get one that matches the criteria of the control. Then you pick the trip value here. Now we know that most most oils in the compressors break down once it gets over 275 degrees. We also know that if we place that sensor 12 inches away from the discharge of the compressor, we know that that should have cooled significantly to that point to get there from the heads. So if we set our trip value at 225 degrees, we are automatically protecting our compressor from such things as over temperature due to anything from, let's say, a defective condenser fan, something in the condenser circuit that would create the temperature to go up enough where we're going to possibly damage the oil. So this is a protection which will also keep the compressor from running at too high a temperature. You can use an oil temperature sensor. The beauty of the oil temperature sensor is that it's dual fold. So if you say yes to this, the next thing it asks you is what type, same as the other. You can choose your type of sensor. And this is critical. The oil can trip on a high and a low. So if I set it for both, which is set for now, so you can set the high trip point for the temperature of the oil, and you can set the low trip point. The important thing about that is that if you put an oil sensor in the compressor and you set high and low trip, you are protecting against oil breakdown on the high end and against liquid slugging on the low end, since we already know that if the unit gets liquid refrigerant starting to slug back, the first place it's going to go is down into the oil sump, and it's going to lower the temperature of the oil dramatically as it boils off and starts to take the oil with it. So this would be a great protection for the compressor for both slugging or for too over temperature, which would break the oil down and cause it to fail too. Back to the main screen, okay? So you always end up coming back to the main screen after you're done. Last one is how your trips are set up. How you set up the alarm trips. You can pick the number of trips until it goes into manual reset. You can choose the delay time that it's going to stay in manual reset until it tries to start itself again. And you can choose how it decides to send an alarm. Now you can set this thing so it only sets an alarm if there's a manual trip. But if you're in a critical environment, you may want to set it so it can set up an alarm even if there's no manual reset and it just trips out. That way the control may reset itself, the problem may resolve itself, but the end user is still made aware that an event occurred that it may need to address. Okay, let's cover a couple other features. This unit does something called taking snapshots. Snapshots are a way to look at what's going on currently. If I push and hold the down button, I get an instantaneous snapshots of all current readings. So if you notice, I have an amp draw reading across ABC, which would be phase 1, 2, and 3. I also have the exhaust, which is your discharge temperature, and right now it's reading oil temperature also. If I hit the up arrow, this would give us an indication of what caused the last trip to occur and also a timeline as to when it occurred. If you notice, all of these things are in plain English. You're not finding any codes, and when you are trying to determine what this control saw, it's telling you in plain English. So let's cause it to trip. So I turn the amp draw on one phase out of bounds with the rest of the phases, and as you can see, immediately it responded. Now, because I had changed the way the alarm was set up, it sent an alarm out immediately, and the control is now tripped. You can see the red light is on up here in the upper top section, and the control circuit light has gone out. So right now, it is in a trip mode, and it says it will reset in 5 minutes. This control will count down. Now, if you were to arrive at the job site and need to know what it occurred, you can sit here and hit that down button. You can see which phase was the one that was out of line, and clearly in this now you can make out that phase A or phase 1 was 13 amps, while B and C were remaining at 8 amps. So you can see what caused it to trip at the point when it occurred. The beauty of this is if you don't get there for a while, it's going to maintain that last trip in there and allow you to look at it and have a direction as to look, and that's pretty straightforward. So we can make this unit trip for multiple reasons. I can take a temperature out of line, which will cause it to trip, or I can take the oil temperature either too high or too low, which will also cause it to trip. And in any one of those cases, this control will automatically go into a protection mode to protect the piece of equipment. As you can note, the trip happens fairly quickly when it comes to phase imbalance or an amp draw imbalance. The beauty of using the CTs is that unlike just a phase protector where we're just looking for voltage, this is reading actual amp draw as the appliance is functioning, as the motor is working. And I say motor because you could apply this to almost any kind of motor that you have that's critical. This does not just have to be on a compressor. This could be on any critical motor application, such as a elevator motor, or a motor on a pump that you can't afford to have go down that you need to know is working correctly. You can actually put this on any one of those applications and achieve the same thing. And because of the sensors, you could change the discharge number to a temperature of a bearing and actually attach it to the end of the motor and take a bearing reading. And if the bearing's getting too hot because we know that, let's say it's starting to wear, you can catch the problem before it becomes terminal and actually take action.